I hope all of you are doing good. Let's start today's chapter, Division of Polynomials. Introduction. In our earlier chapter, we have learned about algebraic expression, the addition, subtraction and multiplication. In this chapter, we shall introduce the concept of division of algebraic expressions and extend it to the division of polynomials. We shall also discuss the relation among the dividend, divisor, quotient and remainder. Degree of a polynomial in two variables. In a polynomial in more than one variable, the sum of the powers of the variables in each term is computed and the highest sums obtained is called the degree of the polynomial. For example, see here is in this expression polynomial is a polynomial and x and y of degree of 6, while in this expression x and y of degree 3, as you can see, right? Next, constant polynomial. A polynomial consisting of only a constant term is called constant polynomial. Its degree is 0. Remember that. Degree of a constant polynomial is always 0. Next is a linear polynomial. A polynomial of degree 1 is called a linear polynomial. Quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. Biquadratic polynomials. A polynomial of degree 4 is called biquadratic polynomial. Okay. Note. Number 1, an algebraic expression is called a monomial, binomial or polynomial according as it contains one term, two terms and three terms respectively. Number 2, every polynomial in an algebraic expression, while an algebraic expression need not be a polynomial. Okay. Let's do exercise 14.1. Write the degree of each of the following polynomials. Number 1, 2x square minus 5x cube plus minus 4. Okay, so what is the degree of the polynomial? It's 3. Okay. Next, division of polynomials. Number 1, division of a monomial by a monomial. We have learned in arithmetic that dividing a number, say 20 by a number, say 5 means determining a number such that when it is multiplied by 5, the product is 20. Clearly, such a number is 4 and we write 20 divided by 5 is equals to 4, or we can also write like this. So, the division of a monomial by a monomial is also defined similarly. Dividing a monomial x, say, by another monomial y, say, means finding a monomial such that x is equals to yz and we write x divided by y is equals to z or z, or you can also write x by y is equals to z or z. So, here x is called the dividend. Okay, so x is what? This is dividend, and y is called the divisor, the number which divides the dividend. Okay, and z is called the quotient. Right. So, while dividing a monomial by a monomial, the following rules are followed. Okay. So, rule number 1 is the coefficient of the quotient of two monomials is equal to the quotient of their coefficients. Rule number 2, the variable part in the quotient of two monomials is equal to the quotient of the variables in the given monomials. Okay. Let's do example 1. We have to divide 15xy square by 3xy. Okay. So, how will you write it as? You will write 15 into x into y into y. 3 into x into y. Now, cancel out. Y goes, x goes, 3 5s. So, answer is 5y. Okay. So, next, division of a polynomial by a monomial. There are two convenient methods for dividing a polynomial by a given monomial. Method 1, we follow the following steps. Step 1, we consider the separate terms of the polynomial. Step 2, divide each term by the given monomial, and step 3, we add the quotients. So, we shall consider two examples. Example number 1, let's check out what does this say. So, we have to divide here 6y4 plus 9y cube plus 12y square plus 15y by, we have to divide by 3y. Okay. So, what is the step 1? What does the step 1 say? The terms of the polynomial are given here, 1, 2, 3, 4. Okay, these are the terms. And step 2, we have to divide each term by the given monomial, which is 3y. Okay, so 6y raised to the power 4 divided by 3y. Okay, then 9y cube divided by 3y, 12y square divided by 3y, and 15y divided by 3y. Okay. Okay, now what will you write? 3 2s are 6, 2y cube plus 3 3s are 9, 3y square, then plus 3 4s are 12, 4y, then plus 3 5s are 15 and y goes, so 5. So this is the answer, right? Similarly, you will do other examples also. Okay, now let's check out the method number 2. In this method, we factorize the given polynomial in such a way that one of its factors is the given monomial and then carry out the process of division. Okay, for example, we have to divide this. So the question is 5p cube minus 10p square plus 8p. We have to divide this by 5p. Okay, so let's factorize first this expression. So after factorize, first we'll find the common factor. Common factor is p and we'll take 5 as well. So here we will write p square minus 2p plus 8 by 5. Okay, divided by 5p. 5p goes and the answer is p square minus 2p plus 8 by 5, right? Next, division of a polynomial by a binomial, factor method. Okay, so in this method we factorize the given polynomial in such a way that one of the factors is equal to the binomial with which we wish to divide. Then we cancel out the common factor and get the answer. Okay, for example, let's do the example number 1. X square plus 4x minus 5, we have to divide this by x minus 1. So first what will we do? First we will factorize this. Okay, so how will we write it as? 1 into 5 is 5. So we have to find two numbers. After multiplying we'll get 5 and after subtracting we get a 4, that is 4x. Okay, so what could be the numbers? Yes, 5 and 1, because 5 into 1 is 5 and 5 minus 1 is 4. So here we will write 5x minus x. Okay, so now factorize this. X square plus 5x minus 5 x minus 1. X plus 5, here common minus 1, x plus 5 and then x minus 1. Now x plus 5, x minus 1, x minus 1. So the answer is x plus 5, right? Next, division of a polynomial by a binomial, long division method. It is not possible always to factorize a given polynomial so as to divide by the given binomial. So in such cases, the method of long division comes to play. Okay, so we shall explain the method by means of some examples. So example 1 is given here. So we have to divide this expression by 3x minus 4. So we follow the given steps. Number 1, first we write the expression in the standard form. This makes the dividend. Okay, this is the dividend and this is the divisor. Of course, we have to divide this expression, that means this is dividend and this is divisor. Now step 2 is we divide the first term of the dividend by the first term of the divisor, that is we divide 3x cube by 3x to obtain x square. This gives us the first term of the quotient. Quotient becomes x square. Okay. Now step 3, we multiply the divisor by the first term of the quotient and subtract the product from the dividend. That is, we multiply 3x minus 4 by x square and subtract the product from the dividend, 3x cube. Okay, minus 3x plus 27x minus 2. This gives us this remainder. Okay, as you can see here. Okay, now step 4. Now we consider remainder minus 9x square plus 27x minus 20 as the new dividend. Okay, now this has become the new dividend, right? So the divisor remains the same. We repeat step 2 to get the next term of the quotient, that is we divide the first term, which is now the first term has become minus 9x square, okay, by the first term, that is 3x of the divisor. This gives the second term, minus 3x of the quotient, okay. Now this is the second term and the quotient is minus 3x. Step 5, we multiply the divisor by the second term of the quotient just obtained, that is we multiply 3x minus 4 by minus 3x and subtract the product from the dividend. We get 15x minus 20, right? As you can see here, step 6, we treat the above remainder as the new dividend. Now, this remainder has become the new dividend, okay, and the divisor is same. So, we repeat again step 2 to get the next term of the quotient, that is we divide 15x by 3x, we get 5 as the third term of the quotient, okay. So, this is the third term. Step 7, we multiply the divisor by the third term of the quotient just obtained, that is we multiply 3x minus 4 by 5 and subtract the product 15x minus 20 to get 0 as a remainder, okay. So, here we will get a remainder as 0. So, here the quotient, which is this x square minus 3x plus 5, and the remainder is what? 0. So, this process of long division is displayed as follows, okay. So, this is the method of long division, means first we will multiply this x square by 3x and then 4, okay, then we'll subtract. As we subtract, then we'll get remainder, okay, and at last we'll get remainder as 0, okay, right. So, similarly you will do other examples also. Exercise of 14.2, divide minus 9x cube by 3x, okay. 3 3s are 9, minus 3 and x square. This is the answer, right. Next, division of a polynomial by a polynomial, but this time non-zero remainder. So far, we had considered division of a polynomial by a monomial or binomial that divides a polynomial completely without having any remainder. Now, we consider the cases where the remainders are not 0. We know that in case of numbers, we continue division till we obtain a remainder less than the divisor. However, in the case of polynomials, we compare the degree of the divisor and the remainder. We continue the process of division till we obtain a remainder with a degree less than that of the divisor. So, we shall illustrate this with the help of examples. So, example is given here. So, see, this is the dividend and this is the divisor, that is x minus 3. So, writing the dividend in the standard form, we carry on the division process as explained earlier, okay. Now, let us do this example, okay. So, we have a divisor x minus 3 and dividend 5 x raised to the power 5 minus 13 x raised to the power 4 minus 15 x square minus 30, okay. So, first we will consider this term. So, we will multiply by 5x raised to the power 4. So, x into 5x raised to the power 4 is 5x raised to the power 5 and minus 3 into 5 is 15x raised to the power 4. Now, change the sign, okay. 15 minus 13 is 2x raised to the power 4 and we will write these two terms as it is, okay, minus 15x square minus 30. Now, we will write here plus because there is a sign of plus, okay. Now, we will multiply by 2x raised to the power 3, x into 2 raised to the power 2x raised to the power 3 is 2x4, okay, minus 3 into 2 is what? Minus 6x cube, okay. So, we will change the sign, okay, x square, x cube, these are not like terms, so we cannot subtract or add. So, we will write here 6x cube plus minus 15x square minus 30, okay. Now, next we have plus here, so we will write plus. We will multiply by 6x square. So, x into 6x square is 6x cube minus 3 into 6 is 18x square okay, minus plus 0. 18 plus 18x square minus 15x square. 18 minus 15 is 3x square minus 30. Okay. Now plus again, so here we will multiply by 3x. X into 3x is 3x square. Okay. Minus 3 into 3x is 9x. Okay. Minus plus. Okay. These are not like terms, so we will write 9x minus 30. Okay. Next, we will multiply by 9. 9x and minus 27. Okay. Now change the sign, minus plus. Okay. 30 minus 27 is 3 and minus 3. So this is your remainder. Okay. And this is the quotient. Right. So this is the method of long division method, right? So similarly, you will do other example also, that is example 2. Now, a shorter form of long division, we shall explain it by an example. Suppose we want to divide x cube plus 4x square minus 3x minus 7 by this divisor. So we proceed as follows. Okay. First, write the polynomial to be divided in the top line. Leave a line blank. Then draw a line below the line, write the divisor 3 times as shown below. As you can see here, divisor has been written here 3 times. Okay. So what will we do? One by one we will divide it. Okay. So next, as in the usual method, we calculate the first term of the quotient, which is x square, as you can see here. Okay, multiply the first x minus 4 in the bottom line by x square and write the product in the blank line. Okay, blank line. And the term x cube is taken care of. We write 8x square in the middle line. From 8x square, we get the second term of the quotient. We write 8x before the second, that is x minus 3 with bottom line. Now write the product, x is 8x square minus 32x in the middle term. Then we adjust the x term by writing 29x in the middle line. This gives the next term of the quotient. Next, we multiply the last, that is x minus 4 in the bottom line by 29 and write the product in the middle line. Finally, we adjust the constant 109 in the middle line. The final result is shown alongside. Okay, so this is your quotient. Okay, and the remainder is 109. Okay, so here is example given. We have to divide this term by 3x minus 2 by using shorter form of long division. Okay. Now let's do exercise 14.3. Divide the first polynomial by the second. In each case, you have to verify the result. You know the formula, that is dividend is equals to divisor into quotient plus remainder. Okay, so let's divide 5a square plus 7a plus 8. This is the dividend by a plus 2. Okay. So we will multiply by 5a. A into 5 is 5a square. 2 into 5 is 10a minus minus. Okay. Now this has become minus 10a. 10 minus 7 is minus 3a, and then we will write 8. Now here negative sign, so we will write here negative. We will multiply by 3. Okay. So a into minus 3 is minus 3a. 2 into minus 3 is minus 6. Now change the sign. Now it has become positive. 8 plus 6 is 14. Okay. So this is your quotient and this is the remainder. Now you can verify it by using this formula, right? Things to remember. Algebraic expression in which the variables have only non-negative integral exponents are called polynomials. 2. A polynomial that involves only one variable is called a polynomial in one variable. 3. The highest exponent of the variable in various terms of a polynomial in one variable is called its degree. 4. A constant is a polynomial of degree 0. 5. The standard form of a polynomial in one variable is that in which the terms of the polynomial are written in the decreasing order of the exponents of the variable. Number 6, the coefficient in the quotient of two monomials is equal to the quotient of their coefficients. 7, the variable part in the quotient of two monomials is equal to the quotient of the variable parts in the given monomials. 8, when on dividing a polynomial, that is dividend, by a polynomial, that is divisor, a zero remainder is obtained and the divisor is a factor of the dividend. In such cases, quotient is also a factor of the dividend. So hence we have dividend is equals to divisor into quotient, right? And 9, in general, in division of polynomials, we know that dividend is equals to divisor into quotient plus remainder. Number 10, the degree of the remainder is always less than the degree of the divisor. 11, before performing long division, the divisor and the dividend must be written in a standard form. Number 12, while performing long division, like terms are written one below the other, leaving gaps wherever necessary. Right, students? I hope you have understood this chapter. Now, do practice of the remaining questions.